Welcome back to our series on demystifying IPv4 subnetting, and it's time for us to look at the original IP address classes. Yeah, when the creators of TCP/IP decided on their addressing scheme, they broke it up into address classes. So the idea was, let's create classes for different size networks. So they created a class A. The decimal value that you would see in the first octet would be from 0 to 127. Notice what they did. They took the first bit in that initial octet and they set it to a 0. They forced that bit to a 0. You'll see why later on, but that's going to give us the potential for 0 to 127 in that first octet. What is the default subnet mask? It's 255.0.0.0. Now you remember from our look at the subnet mask in the last video, I'm sure you remember that this means the first octet identifies the network. And then we have 3 octets, a whole bunch of bits. That would be 3 times 8 is 24 bits that are available for host addressing. So sure enough, the idea here was the class A address class would be for massive networks. Now, we can't create that many of them. We can create 126 of them, but each of them can accommodate that 16,777,214 hosts. Wow, so Class A defines a small number of very, very big networks. And we remember a numbering scheme like this, we would want to subnet it, sure, because we don't want 16 million hosts in a subnet. In fact, we don't even want to get close to that number of hosts in a subnet. Something else that's very interesting about the Class A when you look at it is 127. Yeah, 127. This is proof that the designers of TCP/IP never thought it would catch on the way it did because, as you probably know, we don't use the 127 address. It is reserved for something called loopback functionality. Yeah, watch this. If I go to my command prompt, I can ping 127.0.0.1, for example, and notice there's an immediate response. I am pinging my own machine because my own machine has a reserved address in the 127 network space, and this is for testing. It's for diagnostic testing. I am pinging myself here to make sure that my TCP/IP stack is set up properly on this machine. Oh my gosh, you can tell, as I said, that they really didn't plan on IP becoming as popular as it did because they sacrificed one of their giant Class A networks just for diagnostic testing purposes. Okay, well, if Class A address classes were designed for massive networks, what about medium-sized networks? Well, sure, that's what the Class B was designed for. It is going to have in its first octet a decimal value of 128 to 191. Notice what they did. They forced the first initial bits of the first 2 bits to 10, and you probably already guessed it, the default subnet mask is 255.255.0.0. There is 16 bits of addressing used to identify the network. The first 2 octets identify the network. This numbering scheme can create 16,384 networks, and each network can have 65,534 hosts. By the way, if you're wondering where these numbers come from, we will actually, in a later video, show you how easy it is to calculate those. Finally, The creators of this great technology said, we need small networks. Sure, there needs to be small networks that are created. So this is the class C, from 192 to 223. Notice what they did. They took those first 3 initial bits and they forced them to 110. The default subnet mask is 255.255.255.0, so the first 3 octets identify the network and the 4th octet identifies hosts. We can create a whole bunch of these little networks, 2,097,152 of them, and each of them can accommodate the smallish number of hosts at 254. If that Class C looks familiar to you, it's because we saw it on my machine, as you might remember. So in the last video we saw in my machine, I had 192.168.0.18 given to me by my local DHCP server, and the subnet mask is 255.255.255.0. So we see this is a classic example of a Class C utilizing that default subnet mask of 255.255.255.0, and remember that indicates that 192.168.0 is the network that I live on. Now, a little bonus material for you in this video. It's very, very interesting, but sure enough, when IPv4 addresses started becoming in short supply, and unfortunately, that is because they gave out almost all of the address space. You might ask, is there anything beyond a Class C? Well, there's Class D, which is for multicasting, and then Class E is for experimental purposes, but those classes are quite small. So they made a little bit of a mistake here when they first rolled this out. They set up a numbering system where most of the address space would be given out. This mistake won't be made again. If you look at IPv6 as an example, the next version of our IP protocol suite, sure enough, they're only giving out a very, very small portion of the address space. So when addressing started coming into short supply, they decided to do a fix. They said, let's go ahead and create reservations here from our classes that are for private use only. Yes, and you recognize, look at that, the Class C, 192.168 is indeed private use only. This is why small home offices are being put in this numbering range automatically from their DHCP server on their router in the small home office, because yeah, this is great. Everyone in the world can have their small home office numbered in the 192.168 space, and it's not going to consume any public IP addresses. So lots for us to kind of memorize in this video, and flashcards will certainly help you. Notice the reserved Class A space is anything that begins with a 10. So if we see a 10.x, as we like to call it, address, it is private. The tricky one here is the Class B. Notice it's a series of Class Bs that were reserved from 172.16 to 172.31.255.255. So if we see in the first 2 octets 172.16 or 172.17 or 172.18, you get the idea, all the way up to 172.31, those are all private reserved address ranges. Well, while there's a lot that you might want to commit to memory in this section, I want to remind you, yeah, flashcards can really help, and it will become easier and easier and easier for you as you go, trust me, as you start practicing and working with these IP addresses. While some students may find it a challenge to recognize a private IP address early on in their education, it gets really, really easy when you start working with IP addresses a lot more often. And as far as some of the memorization that goes here, well, notice the default subnet masks. Pretty easy to memorize, right? Starting with the first octet, then moving to 2 octets, then moving to 3 octets. And as far as the decimal number you would have in your first octet, notice it goes from 0 to loopback. Then it goes from the loopback, if you will, up to 191, because the next range is 192. We can think of 192.168. That's our private address range. So that's kind of easy to remember. So class A ends at loopback, and then we go up to the private IP address range with class B. So little hints like that will help you commit this stuff to memory. And as I indicated, as far as the number of networks and hosts, I'm going to actually show you how to calculate that. So please don't be intimidated by everything that we have covered with you in this video. You can certainly watch this video a few times, of course. No one's stopping you from doing that. And as I indicated, I would also highly recommend flashcards as you're just starting out with IP address and subnetting mastery. Thanks so much for joining me here, and I'll see you in the next video.